To find the value of sine, cosine, and tangent of a right triangle, we need to identify where our angle is for theta. Theta will be one of the two acute angles. So here's our symbol for theta. The two legs that form the right angle, those are going to be either opposite, straight across from theta, or adjacent to theta, right next to theta. And then the other side, that is your hypotenuse. So when you take a look at this triangle, you need to identify these three sides, which one is the adjacent side, which one is the opposite side of theta, and then which one's the hypotenuse. So again, the two legs that form the right angle, you're going to want to take a look at where theta is, and the number 5 here, this length of 5, that is opposite. That is straight across the triangle from angle theta. And then the other leg here is touching angle theta. So this is our adjacent side. And then the side that doesn't touch the right angle at all, that's our hypotenuse. Or if you want to think of it this way, it's straight across from the right angle. You could think of it that way too. And then once you know which sides are the opposite, adjacent, and hypotenuse, then you're ready to go through and set up your problem and do your calculations. So we need to calculate the sine of angle theta. I know that the sine of angle theta is going to be a fraction, and it's going to be the opposite over the hypotenuse. If you can't remember, it may help to write down that acronym SOHCAHTOA. And remember that phrase SOHCAHTOA, that is really 3 different formulas. The first 3 letters are SOH, so sine is opposite over hypotenuse. So for this problem, the opposite side has a length of 5, and the hypotenuse has a length of 13. You should simplify that fraction as much as you can, but that doesn't reduce at all. So that's our final answer for the sine. The cosine of our angle theta, that's the middle 3 letters. The C is for cosine, and then that is adjacent over hypotenuse. In this triangle, our adjacent side has a length of 12. The hypotenuse has a length of 13. Again, that can't be simplified at all, so that is our answer for the cosine of theta. And then for tangent, that's the TOA part of SOHCAHTOA. The T stands for tangent, and then that's opposite over adjacent. The opposite side over the adjacent side gives us the fraction 5/12. And that can't be reduced or simplified at all. So for the triangle that was given, the sine, cosine, and tangent of our angle theta are those 3 fractions that are listed there. For this next example, we're going to find the value of all 6 of our trigonometric functions. We're given a right triangle again, and this time we are only given the length of 2 of our sides. We're going to need to calculate the length of the missing side. In this case, our missing side here is our hypotenuse. To calculate the length of a missing side, when you have 2 of the 3 sides of a right triangle, you're going to use the Pythagorean theorem. And if you remember that formula, that's a squared plus b squared is equal to c squared. A and b are the length of the 2 sides that make up the right angle, the 2 legs. And then c, that is our hypotenuse. So in this problem, we know a and b. What we don't know is side c. So I'm going to let a be this bottom side here. I'll let b be this leg over on this side. And then c, that's my hypotenuse. So I'm going to have 3 squared plus 1 squared is equal to c squared. 3 squared plus 1 squared is 10. So c is equal to, technically, plus or minus the square root of 10. But when we're talking about side lengths of a triangle, That length of that side can't be negative, so we ignore the negative, even though algebraically it's part of our solutions, it just doesn't make sense for the problem. So C is a positive square root of 10. So I can calculate that the length of the missing side is a square root of 10. That square root that's there should be simplified as much as you can. The square root of 10 does not simplify. There aren't any perfect square factors for 10 other than the number 1. Now that I know the length of those sides, now I can go through and label those 3 sides, opposite, adjacent, and hypotenuse. So again, your 2 sides that form the right angle, those are your legs. Take a look at your angle theta, the one straight across from it, that's the opposite side. The one touching it that's not the hypotenuse, that's the adjacent side. And then the one straight across from your right angle, or the one that doesn't touch your 2 legs, that's your hypotenuse. From there, I can use SOHCAHTOA to calculate the lengths of our 3 main trigonometric functions. So first, let me do sine. The sine of our angle theta, that is opposite over hypotenuse, so that's 1 over the square root of 10. I should simplify that as much as I can, leaving a square root in the bottom part of a fraction. That's not a good idea. For our final answer, we're supposed to rationalize that. To rationalize a fraction with a square root on the bottom, you're going to multiply the top and the bottom by that square root. So I'm going to multiply top and bottom on this problem by the square root of 10. If I multiply straight across the top and straight across the bottom, I have the square root of 10 over 10, and that is simplified as much as it can be. So the sine of our angle theta is the square root of 10 over 10. The cosine of angle theta, that's the adjacent over the hypotenuse, so that's 3 divided by the square root of 10. Again, we do need to rationalize here. And then multiplying straight across the top and straight across the bottom, I get 3 root 10 over 10. I should see if that is simplified. It doesn't have the square root in the bottom, but I do have a regular number 3 in the top and a regular number 10 in the bottom in the fraction 3/10. If we can reduce that, we should, but 3/10 does not reduce, so the cosine of our angle is 3 root 10 over 10. The tangent of our angle theta is opposite over adjacent. That's the TOA, part of SOHCAHTOA, and that is the fraction 1/3 for this problem, and that is simplified as much as we can. So there are our 3 main trigonometric functions for this problem. We were asked in the directions to find all 6. What I need to do now is take each one of these 3 and then flip them over to get the 3 reciprocal functions. When you do that, you can do that a few different ways. In order for us to do the reciprocal of sine, or the cosecant of our angle theta, I could take our final answer here and I can flip that over. If I do that, I'm going to have 10 over the square root of 10. That is our value for the cosecant, but again, that's got a square root in the bottom, so I should simplify that. I'm going to rationalize that by multiplying top and bottom by the square root of 10 like I did up above. If I multiply straight across the top and straight across the bottom, I'll have a 10 times the square root of 10 over 10. I do have a regular number 10 on the top and on the bottom, and these do reduce this time. So I should reduce, in this case, even cancel those square root of 10s out. So the cosecant is the square root of 10. That's our final answer for that. So sine, its reciprocal is cosecant. So I just need to take my answer for sine and flip that over and then simplify. There is a little shortcut that you can do on some of the problems some of the time. The fractions that I had up here in pink for sine, are actually both the same number. They're both the same decimal. If you looked at 1 divided by the square root of 10 on your calculator and looked at that decimal, and then you looked at the square root of 10 over 10, that's the exact same number, just written in a better form. So actually, I could take either one of these pink fractions and flip either one of them over to get cosecant. If I take my final answer and flip it over, I'm going to be taking this square root of 10 and flipping it to the bottom, which is fine. I can simplify that. But it is actually smarter and faster for you to take a half second and just pause and take a look at the work that you've shown and see if there's another fraction that's equal to your final answer that you could flip over to get to your answer a little bit more quickly. And in this case, it would be 1 over the square root of 10. If I take that fraction and flip it over, I would have the square root of 10 over 1, or the square root of 10, and that would be a better option. So let's do that for our next reciprocal function. The reciprocal of cosine is secant. I could take my final answer for secant and flip that over. That would be fine. It would take this 3 times the square root of 10 and move that to the bottom part of the fraction, and I'd have to rationalize. So I'm going to take a half second, go back to the work I've shown, and see if there's another fraction that it's equal to that I could flip over that wouldn't have the square root on the bottom. And that's this 3 over the square root of 10. If I flip that over, I'm going to have the square root of 10 over 3. And that's our final answer. That doesn't need to be simplified at all. If I had taken 3 root 10 over 10, and I had flipped it over and rationalized and then simplified it, this is the answer I would have come up with. Finally, we have the reciprocal of tangent, which is cotangent. This one's a nice easy one. We just need to take the reciprocal of 1/3, which is 3 over 1, or just 3. So we were asked to find the 6 values for our 6 different trigonometric functions for this problem. In the original problem, we only had 2 of the 3 sides in a right triangle, so we needed to use the Pythagorean theorem. And then from there, use SOHCAHTOA to come up with our main 3, and then flip those over to get our reciprocal trigonometric functions.